Hello, good people of the SST. Today we're going to be talking about wave vocabulary and reviewing how transverse waves and longitudinal waves are different. As a quick reminder, before I get started on the video, you can speed me up or slow me down if I'm talking too fast or too slow to fit your perfect pace. But let's jump right in. So right here, this is a transverse wave, right? Because we can see that it's moving up and down and rather than left to right. And so what we want to do is we want to be able to define how far a transverse wave moves up. And that's going to be our amplitude. And so the first misconception that people get when they're talking about amplitude is they measure the amplitude from the bottom all the way up to the top. So our first misconception is that amplitude is actually from the midpoint, that midline right there, this purple line to the top, right? So if we were measuring the amplitude right here, which we can also do going down, we would notice that it's this distance right here, rather than this whole distance right here. We don't want to look at this whole distance and say that's our amplitude. This is incorrect. In addition to defining how tall our waves are, we also want to define how long they are. And that's actually a really easy vocabulary term to remember because we just combine the name of our unit with how far our waves are moving. And so we call that wavelength. And so it's really easy to remember because it's just going from the top all the way to the other top. But be careful because this is also a very easy place for students to make mistakes. This is our second misconception. And so remember that the wavelength is not from the midpoint like here because that is a shorter version of our wavelength. A lot of students will take the point that it crosses and look at that. Ideally, go from the very top to the very top. If you start at the center though, remember to go all the way up, all the way down, and then all the way back up to that point again, right? And so the wavelength has to stem from the bottom all the way over to this side right here, right? From this point to this point. And finally, with transverse waves, we have a fancy term for top, which is just crest, and trough, which just means bottom. And so if you have any questions about transverse waves, this would be a good time to pause the video and ask your teacher if anything didn't make sense. But if all that seems clear, we'll move on to the next type of wave, which are longitudinal waves. And so here, there's a bit of a difference. And this is the third and final misconception that students make, is that they look at this and they compare it to the other one and they say, all right, so this kind of looks like that sine wave I saw earlier. And so maybe our wavelength is this distance right here, right? Do you kind of see what I'm drawing right here? Looking at that distance. And unfortunately, with longitudinal waves, we're actually looking at the difference between compressions. And so our wavelength is actually much larger than that. It's between the 2 points where the wave is compressed, and you can see these are labeled as compressions. And so longitudinal waves have two fundamental parts. They have the part where they're being compressed, which is right here, and then they have the part in between where they're being stretched out. And physicists have a special name for that term in between, which is rarefaction. All right, so just as a quick review, when you are labeling your transverse waves, make sure that your amplitude stems from the middle to the top, right? Make sure that your wavelength is from the crest to the crest. And then finally, with longitudinal waves, make sure that you're not looking at this tiny little spring right here, that you're actually looking at the full wavelength, which is between compressions. Thank you very much. If you have any questions, feel free to reach out to us in the chat. Have a good day.